Okay, thank you for the introduction. We talk about the material that we can find in our bridges. In particular, I will focus on steel rebar. And our goal is to define a possible strength for age curves in order to predict the strength of this rebar without doing any test. And I will show you how we can get this type of prediction model. And I will show you also some applications in two Italian reinforced concrete bridges. So, as you know, we had this terrible collapse in Italy last summer, but this is not, unfortunately, an Italian problem, but because, as you can see in this report that you can download by the internet, bridges fail all over the world, and in the specific case of the Italian bridges, this is not only a problem of safety, of course, which is the main problem, but it is also an historical and cultural problem because with this bridge we lost part of our history. So our cultural heritage, such as the Morandis Bridge, should be protected according also to our constitution, the Italian constitution. And of course, for doing this, as all the speakers have shown before, we have to assess the strength of existing reinforced concrete bridges. And in many cases, we have to test or we have to assess the properties of materials without doing any test, because in many cases you have to assess the strength of thousands of bridges, and you cannot do any direct or indirect test. So in the specific case of steel rebar, can we predict the strength that we can find in the bridges without doing any test? So, for our opinion, yes, we can do it. And we can try to do some, let's say, an analogy with the weight for ages curves that the World Health Organization has introduced for assessing the health of children. As you can see, here, according to the age of the babies or of the children, you can find the right weight or the right age in order to assess their health without doing any test, blood test or something like that. So we would like to do the same also for the tensile or yield strength of steel according to the age of the rebar. So for doing this, the World Health Organization used a database of about of the data taken on about 80,000 children. In this case, we need a database for the existing materials. And in my university, Politecnico di Torino, we have been certifying the quality of materials that we used in the northwest of Italy. In particular, during the construction, part of the materials used is selected and tested in our laboratory. Our laboratory is a certified laboratory, is a national laboratory. And with this test, we certify if the material used in the construction site correspond to the material, let's say, designed by the that the designer would like to use. So we tested both concrete and steel, or reinforced concrete structures. And in particular, in our case, we have the test that we do for steel. And for creating the strength for edge curves, we used about 17,000 tests that we performed from 1908 to 2005. So, and this is the database for the strength for each curve that we can use for creating this prediction model. So here we have one of the certificates we release. It is of 1965. It regards 7 rebar. This is the type of steel, and you can see there are also data regarding the construction site and the hour. These are the results. In the first column, we have the number of the test. The second column here is the diameter of the rebar, the cross section, and then we have the yielding strength, both in the in the tensile load and the stress, and the same for the load at failure. So another data that we can obtain from this certificate is the elongation after failure. So for creating the prediction model, we have some problems. We had some problems because over the year, the type of steel was not the same. So up to the 40s, there was only one type of steel. But after 40s, we had these different types of steel. And as you can see, the percentage of use of this steel among the years is completely different. And if you see, for instance, in this part of the last century, if you compare among two, let's say here, two type of steels, for the same here, you have a different value of tensile strength. And the difference could be also 100 megapascal, so it's quite high. So the first problem is that in the same year, you can have steel of different qualities. Another problem is the diameter of a rebar. The strength could be different depending on the diameter. These are the distribution of the most used bar diameter that we have that we had in Italy in the last century. And as you can see, in this range of years, generally the strength of the largest bar, of the largest diameter, is lower than that of the lower diameter. So the strength also depends on the diameter of the rebar. So in order to create a simple model, of course, we defined we introduced this relationship, and in particular, this relationship is based on the type of materials that we use in a specific year. So here we can consider both the tensile strength or the yield strength. And as you can see, we weighted the average value of these strengths according to the percentage of use of a particular steel in a specific year. So these are the results we obtained for the tensile strength and yield strength. From the database, we obtain all these dots here. And as you can see, all these dots can be approximated by a linear relationship, which is the strength for each curve. And as you can see here, in the beginning or before 1940, there is a large dispersion of the ultimate strength. Regarding the yield strength, the approximation, the linear approximation is better. But of course, there is one problem. Before 1940, we cannot find the value of yield strength in our certificate because it was not measured in that time. So anyway, we can propose these two strength for age lines, and we can check if these two lines works or not, according to the test that we performed in some bridges. Here we have a comparison between the yield strength obtained with our model. This is equation 3, and it is in comparison with the value suggested by the AASHTO Manual for bridge evaluation. As you can see, our model is less conservative than the value suggested by AASHTO, except for the grade 60 still around the 60s. So let's see the application of the models that we introduced. Here we have our first bridge. It was built in 1939. It was made with the Hennebeek system, so it was one of the first bridges that we built around Torino. And from these bridges, we extracted 11 rebars, 11 pieces of rebars, with a diameter between 5 and 30 millimeter, and tested them in tension. So here we have the comparison between the prediction model, the two lines, and the results from the test. So regarding the tensile strength, you have a large dispersion of the tensile strength that we obtained from the test. And of course, the average value, which is here, is lower than that predicted by the model. So what we can say about this, that if you want to obtain the tensile strength, the average value of tensile strength, 11 destructive tests are not sufficient because there is a large dispersion. On the contrary, regarding the yield strength, the dispersion is not so large, and the average value is quite close to the prediction of the model. So in general, this is the value that we use in the calculation or in the design of the bridges. This is the application on another bridge. We are in the 1972, and here we extracted 15 pieces of rebar, and the diameter is between 10 and 26 millimeter. So with respect to the results of the test, we have a large dispersion, also in this case, regarding the tensile strength. Anyway, in this case, we have the average value quite close to the prediction model, which is this line. As in the previous case, regarding the yield strength, we do not have so large dispersion, and also in this case, the average value is quite close to the prediction model. So we can conclude we introduced the strength for each curves from the database that we have at Politecnico di Torino mainly. And from the test on existing structures, we have confirmed that the strength, both tensile strength and yield strength, are increasing over the year. And in general, the proposed prediction model seems to be less conservative than the values of yield strength suggested by the AASHTO Manual. Thank you for your attention.
Thank you very much. We have time for questions. Come to the microphone if there's any.
I'm just curious, was the database mostly bridges or buildings or both?
No, everything
Okay.
is full of all the reinforced concrete structures that we had
Okay.
at that time.
So how close do you think Italian steel is to American or Canadian steel? Is it the same basic chemical formulas?
I'm not so sure about it.
Okay.
But anyway, the problem of assessing the bridges in Italy is quite a new problem. So if you want to follow some rules or some approaches, you can use the AASHTO Manual. And in that case, the prediction of strength, yield strength, is quite conservative with respect to our steel.
Okay.
I'm not sure if the composition or the performances of the rebar, Italian rebar or European rebar, because we also import steel rebar, is the same as in the US or Canada or other countries.
Okay. Thank you.
You're welcome.
Kind of along the same lines. I mean, especially for the ultimate, the FSU, the variation was huge. And I think the second example was 1980, which is very recent, I guess, modern steel. Do you know what the source of that huge variation was? It is quality control, or is there any explanation?
Yes, I don't know exactly the reason of such a large dispersion. Recently, we control it because in addition to the strength, we also measure the elongation after failure. If you increase the elongation after failure in general, in order to have more ductile materials, the strength reduces. So maybe in the last years with the quality control, the dispersion is not so large. We have observed this from the recent tests that we perform on materials.
Any more questions? Yes?
I had one more along the same lines. If it's such a big dispersion and you fit it with a linear correlation, could there have been a better fit with a curve that changed in earlier years and went linear at the end?
Yes, maybe yes. At the moment, we have taken only few data from the database. We didn't consider all the possible tests. So in the future, I suppose that we increase the number of the data that we have from the database, and maybe this curve is not linear as I proposed now. But anyway, the dispersion is mainly on the ultimate strength. The yield strength is quite linear. And this is I think the most important, the most interesting aspect, because we use generally in our calculation, we use the yield strength.
Do you have any idea what the designer's grade or designer's tensile strength was in relation to what the actual strength was in any of the bars? Like today, we have grade 60 rebar, and the actual strength, actual yield strength might be 70.
Oh, yes, we have an idea, but in many cases, you don't know the type of material that you are using. Because in the same year, you have, for instance, in the last years, we used FEB 44 or FEB 32, but if you don't have any data, you don't know the type of steel that you are using. Anyway, we have according to the type of steel, code rules all over the air fixed the value of yield strength and ultimate strength. Yes, so if you know the material, you can obtain this data from the code rules that we had in the past.
There isn't any more questions. Thank you very much.